But first, introductions. Hi, everyone. Steve Kearns. I'm the product lead for our platform group. So I'm responsible for a lot of the core products and capabilities that underlie everything that Ash and Shai were talking about. So Elasticsearch, Kibana for the user experience, machine learning for anomaly detection, and so forth. All of these areas are areas that I've been focused on for quite a long time. I've been with Elastic for 8.5 years. So it's really exciting to be back. I'm remembering all the way back to 2015 when we had our first really big ElasticON for the public sector. It's really exciting to see everybody in person again and actually have these discussions live. So today, I want to talk a little bit about the evolution, right? Ash touched on this briefly. The evolution of Elasticsearch over the years from sort of where we began all the way up to what does it look like when Elasticsearch is a fully managed serverless product where you spend a lot less time thinking about the nodes and the shards and how the nodes and the shards work together, sometimes against you. So I just wanted to walk us through some of the history in terms of how we got here, how the system works, and how we're evolving and moving it forward. And when you think about it, Shai touched on this pretty well. When you start, back in the very early days, you think about how are people going to use this search engine that we're building, these amazing capabilities. Certainly there's going to be, classic search use cases, a product catalog, a parts catalog, maybe logistics or tracking packages and things like that. And the data volumes there start small. And then, well, if I'm going to do logistics, maybe I'm going to track this package in real time as it travels across the country in trucks and switches locations and things like that. Suddenly you're into terabytes of data. And then you start to look at the systems and the monitoring use cases, logs, metrics, infrastructure, the observability area. Suddenly we're talking petabytes. And from a place where you start thinking your product catalogs, you've got millions, tens of millions of these records. Now suddenly you get to security events. And if I'm looking at network traffic data, we've got customers not far from here doing tens of millions of documents per second, monitoring real-time network traffic. And so the range of use cases, when you think about what we're trying to support in Elasticsearch, are very wide. At the same time, when we start to set out what problem are we trying to solve as we continue to evolve Elasticsearch, we say, well, first you need a platform for this kind of data analytics, right? In some cases, this is search. Other cases, this is relevance, right? Bring me back the best top 10 results for this given data set, for this given use case. In other cases, it's, hey, find me the unusual behaving machines, find me the unusual users, find me the unusual systems or services. And we need to be able to provide these capabilities across that range of data, right? It's not just about the volume, but it's about how you put it to use. At the same time, as we look towards how do we evolve Elasticsearch, nobody wakes up wanting to manage shards in the morning. Nobody wakes up wanting to have to think about that. And so how do we reduce the administrative burden? How do we reduce the time we need to spend on that so you can spend more time on the mission or on the product or on the goals? And finally, when you think about using a system like Elasticsearch, how do you scale it? How do you make sure that it's cost effective? We have so many cases where we've talked to people that said, gosh, I've got these other data sets that I wish I could bring in, but I don't have the hardware, I don't have the resources, I don't have the funding. How do we make sure that those dollars go as far as they can, as far as they should? And so this is kind of the backdrop to a lot of the evolution that we've done of the architecture of Elasticsearch. So to set the baseline, right at the beginning, this is the original logo. It's pretty cool. But going all the way back, when you think about how Elasticsearch works today, it was designed from the very beginning to be scalable. So you've got a stream of data coming in, whether it's documents, product catalog, whether it's logs, metrics, infrastructure, security data. When that data comes in, we're sending that to one system, one server. And if you've got more data than one server can process, well, how do you split that data, right? We call that sharding. Right, that's partitioning the data so that you've got the ability to spread this incoming data across multiple machines. And that's great, right? Hits these machines, gets written down to the local disk on the machines, and it's good. But if this is important data, you need that to be highly available, right? If you were to lose a disk or you lose a machine or the network switch, has a bad port, which unbelievably happens, what do? Is the system reliable? And so for that, we have replicas, this sort of resilience. And so when the data comes into Elasticsearch, we write it down, we partition it, we split it across multiple machines if you need to, and then we actually make a second copy of that data and write it down in a replica. So now it's on 2 disks, on 2 different servers, reducing the likelihood of failure really impacting you. And so this idea of scaling and resiliency has been baked into Elasticsearch from the very beginning, and it's foundational, right? This is why it works. This is why it's reliable. This is why it has been so powerful. But at the same time, if you think about this as a flat system, well, this means then all my data has the same cost profile because all the data is being spread across the same kind of machine, the same kind of infrastructure. It also means that as that data ages, it has the same cost, right? Maybe it doesn't need to have the same cost. Is the data that's a year old as valuable as the data that just came in today? Probably not. I'm probably not going to be searching it as much. But in a flat architecture like this, you have to start to think about these things. And then same thing, right? You have to provision your infrastructure for those peak loads. And so some of these foundational challenges were clear from the very beginning. And that's where we started to think about tiering. This idea inside Elasticsearch of being able to make choices to say, hey, in some of my data, I need really fast performance, and I'm willing to pay for it to be fast and performant. And in other types of parts of my data set, maybe I don't want to pay quite so much for the archival data, for the data that's older, for the data that we're keeping for regulatory reasons but aren't going to use regularly. So how do I reduce the cost? And so for that, we've introduced over the years these capabilities. We call it data tiering. And a feature called Index Lifecycle Management lets you define these policies that say, hey, as data comes in, let's initially put it on our fastest and most expensive infrastructure, but as it ages, let's move that data from systems with lots of compute and NVMe drives, and let's maybe move that to servers with less compute, less expensive, and maybe spinning disks. And so you increase the data density and decrease the overall cost. This is wonderful because the way the system works, it's seamless to you as the user. You're just accessing the data, you're setting the time range in Kibana or in your queries to the range that you want, and you're able to query and access that data transparently. And so the nice part about this is that you then get control over, hey, what are the different profiles that I have? What am I willing to pay to store this data? And you get to choose how that works. And this has been really great for us in a lot of different ways. But still, what if you have to keep the data for even longer? What if you've got 100 terabytes of data coming in every day and you have to keep it for a year or 2 years or 5 years? How do you handle that volume of data while still making it accessible and useful? And so over the years, actually first introduced about 3 years ago was a feature we call searchable snapshots. And this was really the first time inside the core of Elasticsearch that we decoupled the compute, the sort of servers doing the search work, from the storage. And in Elasticsearch and in our products, we've had this ability to take snapshots or backups, snapshots is what we call them. And this ability to have the backup go to a low-cost but reliable object store has been a really powerful sort of capability from a reliability standpoint. But then you start to say, well, gosh, what if we could actually search the data that was stored in this object store? And that's exactly what we ended up building with what we call our frozen tier of searchable snapshots. It lets you keep the data, keep the indexed data, these indexes that we create, highly efficient, compressed on disk, very efficient to query, but let's store them only in the object store, and let's query that, pull down just the pieces of those indexes that we need to match the requests. And so this idea of data tiering, we just extended it one step further, so you're no longer keeping the data on the disk of a server as its reliability, and then you need it on 2 when you're relying on a local disk of a machine. We can actually rely on the object store to handle that for us, and then we can just bring as much compute as we need. And so this idea of data tiering has been very powerful, but this idea of using the fact that we can decouple the compute that does the search from the storage means that we go from a 1x cost for the hot tier to 1/20th or something along those lines of the cost for the frozen tier. And this is phenomenal when you have a lot of these archival use cases. But what's interesting, one of the things that we found was this, the performance, the speed that you get of querying the object store was actually not as bad as you might think. And then we started to ask ourselves some questions. Maybe we could use this more.Maybe we could rely even more on the object store to further decouple compute and storage for more of the architecture. And that's exactly what we're going to talk about next, which is the stateless architecture for Elasticsearch. Ash touched on this just very briefly, but when you look at the way the architecture works, right, going back to the original picture, when you write data into Elasticsearch, we're writing it to the disk of a server, and then we're writing it to the disk of another server for high availability. And so that means you're doing this work to index the data 2 times. You're storing it on physical machines and disks 2 times. And this comes with a cost at both compute cycles and in storage on disk. The other thing that's sort of interesting about this architecture that I didn't mention before is the way that hot, warm, cold tiering works. where you're writing the data is into this hot tier, right? Your fastest machines with your NVMe drives. But that's also the place where you're doing the most of your queries, right? If most of your queries are on that most recent data, and that server is also doing all the indexing, you've now got your indexing workloads and your search workloads competing for resource. And so how do you make sure that you've got enough capacity? You over provision a little bit. And so these are the kinds of things that we're thinking about as we're doing it. At the same time, the idea of index lifecycle management, it is incredibly powerful. And if you're not doing data tiering today, if you're not taking advantage of decoupling compute and storage with the frozen tier, we should talk, because you should be doing that. But at the same time, it does require you to have some thoughts to really understand elements of your data, understand the cost profile that your program is willing to bear. And it means that we have to move this data around between these tiers. And so this idea of ILM is really powerful, and we should use it today. But when you start to think about a stateless architecture, maybe we can do even better. And the idea of a stateless Elasticsearch is kind of interesting. So imagine, if you will, that instead of decoupling compute and storage just for this frozen tier, imagine it's decoupled all the time. That the primary place that we write data, instead of to a local disk on a server, is actually to the object store. And so then the idea of saying, hey, when the data comes in, we write it to the object store. So now the reliability comes from the object store, so we only need to write it once. So we don't need a second server to go and index the data and a second server to write it to the local disk. We just need to have it written one time. And when you start to go down this road, you can actually then separate out the indexing workloads that are writing these indexes into the object store from the query workloads that are pulling down just the parts of the index that are needed to answer the requests. And this idea of separating the workloads and this idea of only writing the data one time can be really powerful. It allows you to scale these things in different ways. One of the things that we were nervous about at first, right? Elastic is known for speed. Elastic is known for the performance. That's why people choose Elasticsearch and so many times. So how do we still provide good performance in an architecture where the primary data is stored in the object store? Well, the good news is the things that we built for that frozen tier, this idea of a local cache, the idea of pulling down parts of the index or whole indexes if we need to, and keeping them cached locally, that's actually something we've already built. And so from a performance perspective, we still have the ability to provide great query performance and high performance indexing without necessarily needing quite as much hardware. And some of the early tests on this have been very exciting. We took an example with the same exact hardware configuration for what would take 5 servers, right? Across those 5 servers, what's the maximum indexing throughput that we can do when you are writing it to the local disk and then replicating it to the second one and writing it there? What's the difference in throughput? Like, how much faster can we go if we only have to write it one time? And quite a bit faster, as you can see from the charts. And it allows us on the search tier to really isolate those workloads so that we can say, look, the indexing nodes should be fully utilized 100%. And on the search side, maybe we don't need so much compute, but it can be separate from the other compute. And we can actually decide how much we need for a given use case and scale these things independently. And so this idea of separating out indexing and compute, this idea of decoupling the compute from storage across the entire architecture is really what stateless Elasticsearch is all about. Now, that alone is, I think, a pretty interesting set of capabilities, but we wanted to go a step further, and maybe a big step further, because we wanted to actually make the operational parts of Elasticsearch dramatically easier. And how do you do that? You take the servers away, serverless. But the idea here of a serverless Elasticsearch is actually to say, what if we just handled the scaling for you, right? Decoupling the indexing and compute makes it a lot easier in some ways. But what if we were to provide this fully managed service where you think just about, hey, what's the endpoint I'm pushing my data to? What's the endpoint I'm running my queries against? And then the rest gets handled by Elastic behind the scenes, scaling independently to meet the needs at indexing throughput time, scaling to meet the needs on the query side, and giving you that kind of flexibility of not worrying about those nodes or shards. What if we remove the notion of nodes and shards of you having to really know about that? And that's one big benefit of just operations. But the other side is also things like version and version support. One of the things that I occasionally get sad about is seeing people running older versions of Elasticsearch. We've got hundreds and hundreds of engineers continually working to make the product faster and more scalable, more reliable and all that. But it's hard sometimes to operationally upgrade a system. And with a serverless offering, you don't have to think about any of that. That's something that we can handle for you behind the scenes, continually keeping that infrastructure up to date. So as we make Elasticsearch 10, 20, 40% faster or more efficient to store data, you should immediately be able to benefit from that, right? Because we can automatically do those upgrades for you behind the scenes. And it comes with a lot of other benefits, right? This idea of saying, how do I handle peak loads? How do I make sure the system is both scaling up when it's needed and then scaling down and I'm not paying for it when it's not needed, right? If I pause indexing for a day, should I also not be paying for servers to be waiting to index data? Yeah, you probably shouldn't. That would be nice. So the idea here of being able to scale your usage based on what you're actually consuming, what you actually need, is really, really powerful. And so as we think about, what does a serverless Elasticsearch really mean, this is, I think, a big step and a big important part of the value, as being able to keep up to date, being able to benefit from paying for just what you're using. And so if you go back to the beginning, some of the sort of guiding principles, some of the things that we're looking for and focusing on as we're building the stateless Elasticsearch, as we're building towards this fully managed serverless offering, these are the same things that we just talked about, right? You need the same platform level capabilities, that performance, that ability to scale from small use cases to large. And then how simple can administration be? And this is exactly where we're focusing a lot of our efforts. Quite a lot going on in this space. Still early days. These are under development projects that we have, but really exciting and really promising to see where the platform is going. And so again, if you are not already using data tiering, please jump over to the AMA booth. We can help you understand a little bit more about it. But I hope you're as excited as I am about where we're going with the serverless, stateless Elasticsearch and the serverless offering overall. With that, thank you very much, and we'll see you in the conference. Thanks, everyone.